watch this. We'll pop that back up, I'm sure. Hello. Hello. Close it. Okay. So we're getting to the point of being able to talk about volumes. We've talked about surface areas, which are just areas. And we kind of were working backwards. And I was saying, well, what is something that has no dimension? And we're talking about a point that has no dimension. A point is specifying a place in space-time. And the only reason that I can talk about the point, the only reason I can see something here is because if I didn't put something, then you wouldn't know where the point is. But the point itself, as I get closer to try and pinpoint where it is, it'll get smaller and smaller and smaller and smaller in width. It will have an exact position, but it itself has no dimensions. Yes?
What is the outcome physical?
A point, in by definition, in this sense, cannot have any physicality to it, because to exist, it must have within some volume, okay, of space for it to exist, per se. So, if I take this point and I drag it out sideways, I generate something that has a dimension. I generate a line. If I take this point and I pulled it, I generate a line. A line has one dimension, and we call that a length. If I take the line and I drag it into another dimension, I'm going to drag it down. If I pull this down, I then generate a new dimension for that, which we call I'm going to call it a square, and it's an area. This is two dimensions. Dimensions, not dimension. Okay, two dimensions. Has length and width now. 2 dimensions to width. Length and width. Okay. Now here's the key, and here's why volume is so much easier than surface area. I don't have to take a 3-dimensional object and break it down into all of its little 2-dimensional shapes, like we did with surface areas. We always took the surface areas of 3D objects, and we broke them down into rectangles, squares, and triangles, and circles for cylinders, right? Okay. The beauty is, all I have to do to generate a volume is to take the area and drag it into the 3rd dimension. So I'm going to pull the square out, and I generate a cube. And now that we're in 3 dimensions, we have what we call a volume. Okay? This has a length, it has a width, and now it has what we call depth to it. Okay? 3 dimensions, it's a volume, and we call it a cube. That's why when I say, what's the volume of this, we say cubic feet or centimeters cubed. It's the unit we use to discuss that particular property. Okay? We use meters or centimeters or inches or feet or kilometers up here. Over here we use square feet. We use meters squared. We square the units to get an area. And down here I have centimeters cubed, feet cubed, cubic feet they say, and those kinds of things. We also have things called milliliters. Okay, it's an easier to work with unit than cube things. So if you're doing foods class, you'll talk about milliliters, you'll talk about cups and tablespoons, and I gotta tell you those are quite non-scientific, okay, because they're for the kitchen and doing things in the kitchen, not making atom bombs. Okay. Yeah. So this is the beauty of this, is that in order to calculate a volume, all I have to do is drag a 2-dimensional surface straight into a 3rd dimension. And how far I drag it is what I multiply that area by. For example, let's do a couple examples. If I wanted to go from a square, let's do a square, to a rectangular prism, all I do is I take this area of the square, whatever it happens to be, and we'll put numbers underneath in just a second. And I'm going to drag it straight up, and I generate rectangular prism. Oh my, I'm way off on that. I drag it up H, then the volume of the rectangular prism is whatever the area was here, and I pulled it up H. So I take the area and I multiply it by H. The volume, this is a recap of what we saw last week, the volume is equal to the area times how far I pull it up into the third dimension. Very, very, very powerful, very, very, very simple equation right here. And we can get all of our volumes from this till you get to grade 10 when you do cones and pyramids. There's a neat little trick for cones and pyramids. I'll tell you that right now. Plant a seed. All you do is if it's symmetrically being pinched, as you pull it up, you divide by 3. There, a little bit of grade 10 for you. You just divide by 3 when you pinch it up. We'll highlight those as we go through again, but not critical that we know. So at this point. So for example, let's do the volume of a quick rectangular prism. And I'm going to show you a little bit of what you didn't see on Friday, because I don't think that the thing exactly went there. Maybe it did. You can refresh my memory. If I had a rectangle or a square down here, let's make it a square. And it's 5 by 5. What's the area of the square? Yeah. It's 25. 25 centimeters squared. 5 times sine. So I'm actually looking at this on an angle, right? Okay. It's not a parallelogram, it's a square looked at sideways. So I can do a 3-dimensional isometric view. I'm going to pull this up. Let's go, how high up? Good, 10. Yeah. Now this isn't to scale. We'll use our imagination. If I pull that 5 by 5 square straight up 10 centimeters, then what volume do I generate? Yeah. Yeah, I just take the area of one face times the height that I pull the volume through to generate the volume. I got 25 was the surface area, the area of one face, and I multiply by 10 centimeters is my height. So that was centimeters squared. And I get 250 centimeters cubed. Okay, so it's not like super duper rocket science. And the cool thing about this is I can do some really complicated shapes. They might look really complicated, but if I know the bottom area, it's super easy. Because I just multiply it by how high I pulled it up. That's it. So another way of doing this, just to kind of be a little more mathematically thorough about this, is the area of the rectangle, or square in this case, was length times width times height. Jaden, come sit up here. Jaden, come sit up here. Awesome. So, moving forward, we tend to not always go back to the definition of a volume. We tend to just say, oh, I'm dealing with rectangular prisms, length times width times height, and then we just go from there. Okay? That's kind of the grown-up way of looking at it. This is the starter volume way of looking at it, and unfortunately sometimes we start so low that we just get confused on the way up. Quick question? Really?
Yeah.
Oh, cool. Interesting. Yep.
Yeah.
Is it a 3 on a 2 for the cube?
Say it again?
When you put 250 centimeters.
Oh, yeah, I don't know if the smart bird was just giving me a hard time or what. Yeah, that should be a 3. Okay, let's look at another shape. What if we had this shape? Notice again, we're looking at this on an angle. I'm going to say this is 4, this is 3, and this is 5. And I'm going to take this triangle, and I'm going to put it straight up. Let's pull it up. How far?
10.
Again with the 10. And I'm going to pull it up 10. So I get this shape. what's the volume of this shape? Well, let's go back to this first piece. What's the area of this triangle? Notice I have 3 numbers, but I don't need 3 numbers, do I? What do I really need to find the area of a triangle, right?
Base times height.
Good. I have 3 here. One's a base, one's a height, and the other one's called a perfect. A hypotenuse. Good. I don't want the hypotenuse. I just need the other 2 sides, the base and the height. Okay? Which ones are those? What's the area of this guy? Somebody else. Caden, what's the area of this triangle?
Wouldn't it be base times height times length divided by 2?
Nope. I like what you just said, but that's not what I'm asking you. Yeah. What's the area of this triangle? What's the area of every triangle? Base times height divided by 2. Ian, what's the area of this triangle?
Base times height divided by 2, which is 12 divided by 2.
4 times 3 divided by 2. 4 times 3 divided by 2 is 6. I'm going to take the 6. I don't have units, so let's just say units. I'll put a U. Whatever the units are. Maybe it's a light year for all I know. Who knows? I'm going to say 6 units squared is the area of this triangle, and I'm going to pull it up how far? 10 units. So the volume will be 60. Area times 10, and the units are now cubed. Perfect. So I take the area times the height, which is 6 units squared times 10 units equals 60 units cubed. And you're done. Now, I still liked what Caden did. Caden just hopped right all to the very answer. Because what Caden did was he said length times width times height, which is actually I know that's not exactly what you said. You actually made it right. Don't tell me just yet. Length times width times height is the volume of a rectangular prism. Length times width times height. To turn a rectangle into a triangle, we
Divided by 2.
and you chopped that into a triangular prism. So what Caden said is in fact correct. Notice here, I had base times height divided by 2 times height. So another way of saying base and height is length and width. So Caden said this. He said length times width, that's a rectangle, times height, which is a rectangular prism. If I divided this by 2, then I take the triangle area times the height. And you can just put that in the numerator. Length times width times height divided by 2. And that gets you the volume of a triangular prism. There's one other shape that we talked about. Did we talk about it on Friday in the lecture? I don't remember. Cylinder.
Yeah, we talked about it.
It was in the lecture?
No.
Okay, let's do the surface area of a cylinder as an example.
Yeah.
Absolutely, right? Take the circle, pull it straight up. How high is the cylinder? Pi r squared times h. Done. Easy peasy. So the last shape that we want to talk about is the cylinder. I'm going to say the radius of the cylinder is 3 units. So the area of this circle is 27 something. 3 times 3 times 3.14. 28.26. Pi r squared is the area of a circle. Pi times 3 squared is pi times 9. I'm writing out every little excruciating step, which you don't always have to do, obviously. 28.26 units squared. I'm going to take that circle and I'm going to say, listen, you got to get into our dimension, man. And I'm going to pull that circle straight up the distance of h. In this case, what's h? 2. I'm glad you didn't say 10. As soon as you said 2, I was like, oh no, not another 10. I'm going to pull that up 2. So my height here will be 2 units. Volume is equal to area times h, which is 28.26 units squared times 2 units squared. I might be able to do this one in my head. 56.52 units cubed. Another way of looking at the volume of a rectangular prism, the grown-up way, is to say the area is pi r squared, it's supposed to be an r, times the height. There is a area of a rectangular prism, pi r squared times height. Base, which is a circle, times the height. Okay. So these were the assigned homework questions up here. They weren't for homework. Some people did do them. Let's spend the rest of today making sure that we can do those things. I certainly don't want to be moving on. Half of you, a little less than half of you were in band anyway, so you were just hearing this for the first time. So open that up, please. Let's try and get that completed if we can. Tomorrow we'll get an assignment, starting our assignment on this stuff. Volume is very easy, but I am going to throw some more Pythagorean theorem into this stuff. Okay. Big. Yeah.